Gentlemen, you stand accused of MOSFET murder, the destruction of innocent electronics. As you know, when a coil is turned on and off, you can get an induced voltage. Especially when it's turned off, disabling the power can cause hundreds of volts and a huge spark. You can see that spark here. This spark is enough to completely destroy semiconductor devices. To prevent it, you need to put a diode across the coil in a reversed biased orientation, and that will prevent damage to nearby electronic devices like said MOSFET. The diode will protect. Not to say I told you so, but I told you about this last week. Here's the circuit that I built to show the proper operation of a MOSFET and to test the ones to see if they're broken. When the voltage at the gate is raised from low to high, it allows current to flow through the MOSFET, activating the LED that you see at the top. Here it is in action. If we take a working MOSFET and put it in there, we change the gate voltage to low, and the MOSFET turns off. Switch the gate voltage to high, the MOSFET turns on, off, on, off. Notice that it stays on even when you're not connecting it due to residual charge left on the gate. Now, if we swap this out for one of the ones that you murdered, it doesn't matter, it just stays on all the time. In fact, there's a short circuit between the gate and the other two pins here, and so the gate does nothing at all. One way to test whether a MOSFET is working is to look for continuity or resistance between the gate and the other two pins. There should be no connection. You should get infinite resistance between the gate and the other two pins. If we look at a murdered MOSFET, we can measure the resistance and find that there's a resistance of several ohms between the gate and the source and the gate and the drain. That's not good. That means this MOSFET is dead. So let's remember our fallen heroes murdered in the line of duty, and especially remember the champion who could have saved them if he'd only been there in time.